Hi everyone and welcome back again to the Oracle GoldenGate course. In this lecture I'm going to talk about encryption in Oracle GoldenGate. By the end of this lecture you should be able to use the encryption key method and the wallet method to encrypt the network packets, trail files, and database logging credentials. This is the typical structure of an Oracle GoldenGate configuration, and by now you should understand its components. The PRM files shown in the diagram are the parameter files used by the processes. You can configure GoldenGate to encrypt the network packets between the data pump process and the target system. In this case, the encryption will happen in the data pump process and the collector will decrypt the packets. Also, in this case, the network packets will be encrypted, but the data in the trial files will not be encrypted. Another option you can configure in Oracle GoldenGate is to encrypt the data read by the data pump. And in this case, the data will be encrypted in the trial files in the target system. The replicate should decrypt the data before it applies it on the target database. But in this case, the data in the trial files in the source system will not be encrypted. The same way you configure the data pump to encrypt the data, you can configure the primary extract to encrypt the data as well. In this case, the trail files in the source system will be encrypted, and the extract sends the encrypted data to the target system. Obviously, as a result, the trail files in the target system will be encrypted as well. The replicate process needs to decrypt the data before it applies it to the target database. Another encryption option you have in Oracle GoldenGate is to decrypt the credential it uses to connect to the database. In this case, the extract process reads the encrypted password and then deciphers it to connect to the database. The same applies to the replicate process. It can read an encrypted credential and then decrypt it to connect to the target database. So, in conclusion, we've got three encryption options. First, encrypting the data in the network packets. Secondly, we've got encrypting the data in the trail or extract files. And finally, you can encrypt the credential used by the processes to connect to the database. You will learn about how to implement those options in this lecture. As I said earlier, in Oracle GoldenGate, we can encrypt TCP/IP messages, the data in the trail files, and the database login credentials. You have in GoldenGate two main methods to implement those options. You can use either the encryption keys, and this can also be named as enc keys, or you can use a wallet-based method. You will learn about those methods in this lecture. You can use the following encryption standards in Oracle GoldenGate: AES 128, AES 192, AES 256, and Bluefish. Generally speaking, use the AES standards for encryption. However, those standards are not supported by iSeries, ZOS, and Nonstop. For those systems, use the Bluefish standard. To use enc keys method, you need to have a key that will be used for encryption. You can have your own key, or you can generate a random key using keygen utility. The slide is showing you the syntax of using keygen utility. You will pass the length of your key and the number of keys that you would like to generate. In the second step, you give those keys names and save the names and their values in a file called EncKeys. In the second step, you give those keys names and save the names and their values in a file called EncKeys. You save that file in GoldenGate root directory in all the systems that participate in your GoldenGate configuration. After that, you configure the data pump extract process to use the keys in that file. With the RMT host parameter, you use the encrypt and the key name clauses to define the encryption standard and provide one of the keys that you saved in the EncKeys file. The data pump process will then encrypt the TCP/IP messages using the defined standard and the provided key. In this particular case, you need to manually start the collector process. For that, you use a parameter called server. The example in the slide creates collector process that will listen to port number 7809 and use the standard AES-256. It also uses the provided key to decrypt the message received from the data pump. As I said earlier, you can encrypt the data in the trail files created by the primary extract or by the data pump. To do so, create the EncKeys file exactly the same way as described in the previous slide. After that, you use the encrypt trail parameter to instruct the extract to encrypt the data. In the parameter file, you put this parameter straight away before the parameter you use to configure the trail file. Again, you pass the encryption standard and the key value to the parameter. So far, you learned about encrypting the network message and the data. Let's see how you can encrypt the password in the Oracle GoldenGate parameter files and commands using the encryption key method. Again, you need to have the EncKeys file. After that, you use the encrypt password command to encrypt your database login credential password. Although you can use the default key, it is highly recommended to use your own key for encrypting passwords. The example shown in the slide is generating the encrypted password of the password myPassword using the encryption standard AES-256 and the encryption key is myKey1. You use the output of this command to specify the encrypted password in the parameter file. I will show you how to do this in the next slide. You pass the encrypted password to the user ID parameter and define the encryption algorithm and the encryption key. The provided key must exist in the EncKeys file. As you learned in the course, you use the dblogin command to log into the database from the ggsci command prompt. You pass the encrypted password to this command the same way you passed the encrypted password to the user ID parameter. Encrypted password can be used in any command that requires a password. You can see a list of all the commands where you can use the encrypted passwords in the documentation mentioned in the slide. We learned how to implement the encryption options in Oracle GoldenGate using the EncKeys method. Let's see how to implement them using the Oracle GoldenGate wallet. GoldenGate wallet was introduced in Oracle GoldenGate Release 12c. It wasn't available before that version. A wallet is simply an encrypted file that contains master keys. Those keys can be used for encryption. An Oracle GoldenGate wallet can be used to encrypt the TCP/IP messages and the data in the trail files. There is a special kind of Oracle GoldenGate wallet that can be used to encrypt database credential logins. I will talk about it later in this lecture. Wallet files are platform independent, so if you create one in Oracle GoldenGate software installed in a Unix system, it can still be used by an Oracle GoldenGate instance installed in a Windows platform. The key is encrypted using the AES standards. That's why the wallet cannot be used in the I-Series, ZOS, or non-stop platforms. This slide is showing the list of commands that you usually use to manage wallet files. Those commands are easy and self-descriptive. You use them to create a wallet, open it, add a master key, renew master key, obtain information about the master keys created in the wallet, clear the wallet from all the keys, and purge the wallet. To use the wallet for encrypting the TCP/IP message or the data, you perform the following procedure. First, you create a wallet if there isn't one already. Simply use the command create wallet as shown in the slide. If there is already a wallet created, use the command open wallet instead. After that, you add a master key to the wallet using the command add master key. Then you get the current version of the added master key using the command info master key. For the newly created master keys, its version will always be 1. To obtain the hash key of the master key, use the command info master key version, followed by the version that you got from the previous command. Take a note of the hash key returned by the command. Copy the wallet file to all the systems in your configuration. To encrypt the network message, in the data pump parameter file, use the option encrypt in the RMT host options parameter. To encrypt the data in the trail files, use the parameter encrypt trail in the extract parameter file. By default, Bluefish encryption standard is used. It is highly recommended to use one of the AES standards instead, if your databases support them. In the replicate process, the data will be automatically decrypted using the wallet file. However, if you want to process the data before you apply it, you need to decrypt it first using decrypt trail parameter. If you want the data pump to decrypt the data before it writes it to the remote trail files, use the parameter decrypt trail in its parameter file. It is part of the known security best practices to frequently change the passwords. Consequently, as an Oracle GoldenGate administrator, you may be asked to change the master key of the wallet. To do that, you follow the procedure as shown in the slide. First, you stop the extract process, then wait for the replicate to apply all the pending data. Send the replicate the status command. If that command displays EOF in its output, it means that the replicate has applied all the data in the trail files. After that, stop the replicate. Open the wallet and confirm the master key version in it using the info command. In the trusted source database, you renew the master key using the renew master key command. Obtain the new generated hash value and update it in the parameter files of your configuration processes. Finally, start the processes. As a concept, you can use the wallets to encrypt the passwords in Oracle GoldenGate. However, Oracle GoldenGate uses a wallet for storing the passwords different from the one it uses for encrypting the TCP/IP message and the data in the trail files. This mechanism is considered to be part of what's called Oracle Credential Store Framework. the wallet file generated by Oracle GoldenGate to store the encrypted passwords in it is called credential store. This method is the preferred method for encrypting the passwords in Oracle GoldenGate. However, it is not supported in iSeries, ZOS, and non-stop platforms. To create a credential store to save the passwords, use the command add credential store. The credential store saves the user IDs and their encrypted passwords that are used by Oracle GoldenGate processes to interact with the databases. Alter credential store add user to add a username and password to the credential store wallet. Provide an alias to each credential you add to the credential store. Alter credential store is also used to replace or delete a user alias from the credential store. You use that alias in the parameter file of the processes. I will show you how to do that in the next slide. If you want to use a credential saved in the credential store to log into the database in a process parameter file, use the parameter user ID alias followed by the alias of that credential. If you want to log into the database in GGSCI command prompt, use the command dblogin user ID alias followed by the credential alias. This table is a summary of everything we have learned in this lecture. It is a brief of how to use the enc keys and the wallet to encrypt the message, the data in the trail files, and the database logging passwords. In this lecture, you learned how to use the encryption key method and the wallet method to encrypt the network packets, trail files, and the database login credential. You will learn in the next practice lecture how to use the wallet, how to implement wallet encryption. See you over there. Thank you very much. هذا بتسكروا هيك بعدين بتروح لهداك.